Hello, everyone. In this chapter, we're going to talk about regression models. First of all, we're going to talk about what is a simple regression model. What are terms involved with regression models? And then we're going to talk about scatter diagrams. Basically, we want to know the trend using scatter diagrams. And then we're going to talk about the simple regression models. Models are very important, but measuring the feed of the model is more important. So we're going to talk about some the measures for the fitness of a model. Then we're going to talk about assumptions of the regression models. Finally, we're going to talk about how to test the model for significance, and also we want to know how to use Excel tool, data analysis tool, to do simple regression analysis. Let's get started. Regression analysis is a very important tool for forecasting. We already talked about some the forecasting models, and then in this chapter we want to talk about the last one, causal effect model. We want to know what are the factors, what are the effects, and also we want to know the relationships between them. So this is why we wanted to figure out the model. And then after you identify a model, and then you can use a model to make a prediction. Basically, we want to predict the relationships. So this is why we call this the causal effect model. And then we just focus on simple linear regression models. We just look at one independent variable and one dependent variable. We don't look at multiple factors. In other words, we don't look at multiple independent variables. And then we need to understand some terms. Here we talk about dependent variables or response variable, a variable to be predicted. Value depends on the value of the independent variables. It's explanatory and predictor variables we call independent variables. You can check out this relationship. So dependent variables depend on some independent variables. Also, we call independent variables factors. And then you can use this very interesting tool, scatter diagram. Basically, we want to know the general trend between some the factors or some variables, and generally we uh, plot independent variable uh, on x-axis and plot dependent variable on y-axis. Let's look at an example. This is AAA construction example. Let's look at an example here. You can see the AAA sales and local payroll. We want to look at the relationship between the local payroll and the AAA sales. And then we can use a scatter diagram and then to check out the correlation between the payroll and the sales. You can find scatter diagram from Excel. You just click on some of the data and then you can figure out this line. We call this scatter diagram. Basically, we want to use scatter diagram to know some trend. Now we move to simple linear regression model. So basically we want to test the relationships between the variables. Let's look at this model. We can y equals beta 0 plus beta 1 times x plus error, the random error. And y is dependent variable, and beta 0 is constant, what we call intercept. The b beta 1 is the slope of the regression line, and this epsilon, that's the random error. And then x here, just independent variables, right? And then we call this the regression model. We want to figure out this model. But now the question, how to figure out this model? So now we want to use estimated model here. So y hat stands for predicted value of y, and the b0 estimate of beta 0 based on the sample result, and the b1 stands for estimate of the beta 1 based on the sample results. And the x is the response variable, and basically we want to use this uh, estimated model, okay, and then we use the sample to figure out the values for parameters, and then we can figure out regression model. Uh, you can you can predict the sales based on the area payroll, and you can see here we use Y to represent sales, X to represent area payroll, and then we want to minimize errors. Error equals actual value minus predicted value. We already talked about the focus error. Basically, we can see the same formula. We use the actual value minus the focus value. And we use the E equals Y minus Y hat. And then we have an objective. The objective is to minimize the sum of squared error. So we call this measure the least squares regression. Then you can figure out y hat and then x bar, y bar, the average of x, average of y, and then you can figure out the values of the parameters b1 and b0. Then you can figure out that this is regression model. But if you can just find the model is not enough. I mentioned many times in the class when we talk about the focusing, we need to guarantee the accuracy. For simple regression analysis, basically we want to know the fit. So we how to figure out the fit is very important. We want to measure the fit. So that's why we're going to talk about a very important part in this chapter. And we know regression models can be developed for any variables x, y. How helpful is this model in predicting y? Because we know there are some random numbers, but also we want to know how the model can explain the variability of some variables. That's why we want to measure the fit of the regression model. Here we have to introduce three measures of variables: SST, total variability about the mean; SSE, variability about the regression line; SSR, total variable that is explained by the model. And then you need to know the relationship among the three measures. So what are formula for them? All right, let's look at sum of the queries total. SST equals the sum of y minus y bar squared. Sum of the queries error, SSE, equals sum of e squared equals sum of y minus y hat squared. Sum of the queries regression, SSR, equals sum of y hat minus y bar squared. And then you should know this very important relationship: SST equals SSE plus SSR. Later on, we're going to talk about AAA exam. We're going to check out this relationship. All right, here, this example, I'm going to check out the relationship. And then you can see here, this is the y, this is the x, this is the dependent variable, independent variable, and then we can calculate the average, right, for y. And then we can calculate SST and SSE, and then we can calculate the MSR. Now you can see if we add SSE to SSR, and then you can see the sum of them equal to SST, right? So this the relationship is right, right? Now we should know, okay, this relationship. We can check it out, okay, by using this example. Next, we want to know the fit. We want to measure the accuracy, basically. So we want to introduce some of the terms here. Is called the coefficient of determination. The proportion of the variability in the y is explained by regression equation. Basically, we want to use this coefficient to refer to proportion of the variability in y explained by the regression equation. So how to determine the value for a coefficient of determination is r squared. We use SSR divided by SST equals 1 minus SSE divided by SST. So for AAA example, we already calculated SSR, SST, so we can calculate R squared. Then we can say something like this, about 69% of the variability in y is explained by the equation based on the parallel x. This is the R squared. Then we can calculate the correlation coefficient. I think you must be familiar with correlation coefficient. I think you have learned about this term from PALM to 12. So we want to use this correlation coefficient to show the relationship always between 1 and minus 1. You can use R squared to calculate correlation coefficient. So you can see here, I take a square root. Now we can calculate correlation coefficient. For a AAA example, just take square root and then you can see this number. This is the so So we can see here, so we can calculate R for AAA. This is the correlation coefficient for AAA example. We use the scatter diagram. We have seen the trend, so that's why we pick the positive value. So this positive value means there's the positive correlation between X and Y. And then we want to look at it for the pictures. If R equals 1, there's a perfect positive correlation. If R between 0 and 1, the positive correlation like this. And then if R equals 0, so there's no correlation. If R equals minus 1, the perfect negative correlation. Now we know the R values for AAA example, so we can see there's a positive correlation between X and Y for AAA example. Now we have to make assumption for regression models. Basically, we want to look at the errors. So errors are independent, errors are normally distributed, errors have a mean of 0, errors have a constant variance. And then you can plot the residuals where we can see the errors. And then you can estimate the variance. So basically we want to talk about the sample. So we want to calculate the variance for the sample. We can use this formula. We use S squared equals MSC equals SSC divided by n minus k minus 1. N stands for number of the observations in the sample. N stands for the number of observations in the sample. K refers to the number of independent variables. And then for AAA example, we can calculate the S squared, just 1.7188. And then you can estimate the standard deviation. You can calculate standard error of estimate or standard deviation of regression. S equals 1.31. And then you can test the model for significance. This is a very important part to know the model significance, and then we can determine if the values are meaningful. Basically, we do hypothesis testing here. Let's look at this table. You can see here a high R square, it is desirable. This is very high. This is good. It's very good. Right? And then you can find out SSR, SSE, SST. Right? And now look at this part. So you can see here, this is the significance. Basically, we use the p-value. So the common value for p-value is 0.1, 0.5. You can see here, this is 0.0. You can see here, this is 0.0394 is less than 0.05. So this model is significant, and also you can find a coefficient for B0 and B1. Okay, so and then you can figure out the regression model using those values, intercept and also coefficient, slope. You can use Excel solver. Basically, you can use Excel tool, data analysis tool, and then you can specify the XY ranges and check the labels box if the first row in the XY ranges includes the variable names, and then specify location for the output. To put this on the current worksheet, click output range and give the cell location for this to begin. Click OK, and then you can get a regression model. You can get this table uh, here like this. We just got it.